So last time we talked about the value of a perpetuity, and we demonstrated a perpetuity formula that finds the value of a stream of cash flows. So if we have 5, 5, 5, 5, 5 forever, dot, 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 then the value of that stream of cash flows is equal to the coupon payment divided by the interest rate, because that's the geometric sum formula. Or, in this case, 5 divided by 5% interest rate, and you get $100. If we're getting 5 every period at a 10% interest rate, it would be worth 50. So that is that values a perpetuity, which is occasionally useful in actual pricing. But the perpetuity formula is actually a building block that we can use to evaluate different securities. So we know that 5, 5, 5, 5, 5, 5 forever is worth $100. But what if instead of 5, 5, 5, 5, 5, 5 forever, you get 0, 5, 5, 5, 5 forever? So we don't get anything in year 0, but then in year 1, and year 2, and year 3, and year 4, and so on, we do. Well, let's think about, let's ask an easy question. So if I'm going to get 5, 5, 5, 5, 5, starting in, where we get the first payment in year, or I guess we start getting, the interest starts accruing in year 1. So we get, at the end of year 1, we get 5. At the end, and so it's end of year 1, start of year 2, we get 5. What will that be worth in a year? Well, if you think in 1 year, this will look exactly like a perpetuity, right? I earn $5 over the next year and $5 over the year after that, and so on. So next year, this will be worth $100. And I get 5, 5, 5, 5 forever. That's worth $100. Well, that's the present value of that stream. So 5's forever, starting with interest starting to accrue in year 1, is worth 100 in year 1, which means in year 0, it's worth 100 divided by the discount factor, right? Because 5's forever, starting interest at year 1, is worth 100 in year 1, it must be worth $95.24 in year 0, because there's $100 in $5 payments, and just $100 even are equivalent. We can choose one or the other and get the same amount of money in present value. So my 5, 5, 5, 5, 5, 5 forever is worth $100. So now let's compare that with, if I get 5's starting in year 0. So I get my first payment at the end of year 0, second payment at the end of year 1, and so on. And what if I buy this and sell this? Right, I'm going to pay $100, and I'm going to get $95.24. So let's think about those two things. So basically what I have, what I've got is I have two things that I'm buying a 5 forever, and I'm selling a 5 forever starting in at the end of year 1. What are the cash flows going to look like? Well, I get 5 from this, but I lose 5 from the one I sold. So that money's just going to pass through, and I get 0. Same here, right? 0, 0, 0. But in year 1, right, I don't have to pay 5 to the first one, but I'll get 5 from the one I purchased now that starts paying interest that accrues interest over year 1, starting in year 0. So I get $5 there. So effectively, my cash flows are exactly $5. And I can take the difference here. So I have this plus this. So I would end up paying out $4.76, and I would get $5 at the end of year 1, and that's it. And if we use $5 divided by the discount factor, this ends up being the same thing. So the present value of one payment of $5 is equal to the difference between these two perpetual streams of income. So you're probably thinking, well, we already knew how to find the present value of $5. That's not interesting at all. All we do is take 5 and divide by 1.05 if the discount rate is 5%. And that's right, but the interesting thing about this is, what if instead of this security up here paying $5 starting over year 1, at the start of year 2, what if it waits until year 4 to finally pay? Well, now, instead of just getting one $5 payment, we're going to get 3. So I get 3 $5 payments. And now this is not going to be worth $95.24. It's going to be worth $100, right? In year 4, it'll be worth $100. Or excuse me, in year 3, it'll be worth $100 because we're accruing interest starting in year 3. And so the present value of that stream of 5s is only $86. Or we have to wait longer, so it's less. We have to discount it 3 times instead of just 1. So now we're paying $13.62. And if we do this the long way, I can take this, divide by 1.05 squared, and I can do this, divided by 1.05 cubed, and then add those up. I get the same number. What does that mean? So that means we can use the perpetuity formula to find the present value of a stream of cash flows no matter how long it is. It can be, if it's infinitely long, it's a perpetuity, and we use the perpetuity formula. If it's 10 years long, then the value of it is the perpetuity minus the present value of a perpetuity starting 10 years from now. So that formula looks pretty simple. It's just coupon divided by rate minus the same thing, coupon divided by rate, only this time it's discounted by, so that whole thing divided by 1 plus r to the n, or t, however many years however many payments we're going to get. So the first one here is worth $100. The second one here is worth $100, only in present value terms it's only worth $86.38, and so the difference is $13. So this formula here is the formula for the value of an annuity. Now when you see it, it'll be written differently because there's some algebra you can use to massage it into something that looks a little nicer, but the basic idea is the difference between two perpetuities gives you the present value of an annuity, or a series of payments that ends, that only goes so far and then you're done. So hopefully you can see pretty quickly the connection between this annuity calculation, so a series of periodic payments, and a whole bunch of things in finance. So first of all, corporate bonds are really a combination of two things. One, a stream of coupon payments or interest payments that are constant in many cases, and we can value using the annuity formula, and then a lump sum payment at the end, which we value with a simple present value calculation. Car loans. You pay a certain amount of payment until you're done. There's no lump sum payment at the end, so the payments have to be enough to pay off the principal. Home loans. I mean, just about any kind of consumer loan. Preferred stock look like this. They pay a dividend of a certain amount for forever unless the company elects not to pay it. So there are many things in finance that look exactly like a stream of payments, a consistent stream of payments for a finite length of time. And so starting with a simple building block, the perpetuity formula, which is just one fraction, using present value principles, we can derive a pricing formula for all of these different types of debt. So that's where this chapter is going next. So when we go to chapter 3 and start talking about valuing bonds, this is the kind of process that we'll be using. So find the value of that consistent stream of cash flows, find the value of the lump sum, put them together, and find the price of the bond.